Okay, so the last question, 14, okay, 14 for this test portion, okay. And this is the last numerical test. Not sorry, the last question in this test. One more numerical is there. One more numerical test is there rather. Okay, a sound wave travels at a speed of 339 meters per second. Page 187 in your textbook, question 14. If its wavelength is 1.5 centimeter, what is the frequency of the wave? Will it be audible? Meaning, can the human ear hear this sound frequency? That's what the question is saying. So we have to first solve the numerical part and answer that audible part, whether it will be audible to our human ear or not. So question 14 on page 187. So as we read the question, clearly we found that the speed of the sound wave is 339 meters per second is the speed of the sound wave, as simple as that. Okay, then we know the frequency, wavelength is denoted by lambda, 1.5 centimeter. According to the language of the text, is the wavelength of the sound that is involved here. Right, so then small v, we know small v is nothing but the frequency of the sound. Frequency, okay. Now this chapter sound, we have three main formulas there. Take a note there. Frequency here, our speed here is lambda into frequency small v. We can use that. V capital, lambda into small v. Because we see here v capital is their speed, frequency, and lambda. They're asking us to find the wavelength of this sound. So lambda is equal to capital V by small v. Alright, go to question. What is the frequency of the wave? First is we have to find the frequency of what is the frequency? Sorry, what is the frequency? Not lambda, I made a mistake there. Frequency small v is equal to capital V by lambda. Okay, so what is the frequency? Small v we have to find. So small v, frequency is here. Capital V is the speed, 339 meter per second divided by lambda here, 1.5 centimeter, right? Then we can go here and deal with this centimeter first, because SI unit of wavelength is not centimeter, meter. Now, by now we are so accustomed with this conversion of units for length or distance, kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. So we need to change this centimeter 1.5 to meter. This one, I mean, this is fine, so we'll just keep it as this is 339 meter per second. If you want to change centimeter to meter, you're shifting two places, 1 and 2. So one place is 1, 0, 10, 10, 10, another 10. So 10 into 10 is 100. Since you're changing centimeter small to big, you have to divide. So 1.5 has to be divided by 1, 2 zeros. Then this centimeter will go away and meter will come in. That way we are changing the frequency, wavelength, into its SI unit, that is meter. Okay, is equal to small v. Then it's just a matter of calculating carefully, I think. That implies 339 meter per second divided by, now we know very well that when decimal is divided by zeros, they're like 10, 100, 1,000, etc. Decimal shift to the left. So point here 1, 2 places to the left. So starting from here, 1, 2 places will go here. Decimal will shift 1 from here, 1, 2, between 1 and 5 to here, 2 places to the left, accounting for division by these 2 zeros here. So this is meter equal to small v, the frequency. So that gives you here Now if you want, you can bring this small v on the left side, and this one here 339. This meter and meter can cancel, so we may as well do that. 339 by 0.015, and here meter is cancelled, but still second to the power minus 1 is there. So v is equal to this. Now we know that it's easier to deal with fractions without decimal, so let us remove this decimal 1, 2, 3. So since to remove this, shift this decimal 3 places to the right, to remove it we need to multiply by 3 zeros. So we ought to do the same thing on the numerator as well. Only then we would say we are multiplying by 1. Now 5 by 5 is 1, just as that. 1000 by 1000, whatever you got here, put it up, then it's multiplying by 1, so that the equal sign here is still undisturbed or maintained, whatever you like to say. Okay, so next here, if you multiply this, you're going to get here 339 per second. Okay, if you want to put it into this 1000, just keep it like that, divided by, use these 3 zeros to remove the decimal, 1, 2, 3, will become 15. That way there is no more decimal to contend with, right? So we can easily handle it. 5 3s are 15, 5 2s are 10, 0 0, let us say. 3 1s are 3, 3 1s are 3, 1s are 3, 3 3s are 9. So here 2 3s are 6, 2 1s are 2, 2 1s are 2. Then double 0 there. So now per second means this one or 1 by second is the same, which is equal to hertz, because hertz is the reciprocal of second, right? So per second can be changed to now hertz, right? I hope you're getting it. Per second, like this, per second, or hertz is the same, because hertz is the reciprocal of second. Okay, so this is the wavelength of the sound that is involved here. Now, so the frequency is this one, the answer. The second part of the question, what they're asking, let us deal with that. Let me read the question for us. Will this sound, that is 22600 hertz, be audible to the human ear? That's what they're saying. Audible means audible to the human ear. Now, since we know by general information that frequency, audible range of sound for human beings, audible means can hear, okay? Audible means can hear. Audible range of sound for human is the range is 20 hertz. Okay, 20 hertz, general information, to 2000 hertz, 20,000 hertz, sorry. Any sound having a range from 20 to 20,000 hertz, our human ear can hear it. Below or beyond this, we can't hear, okay? So the sound wave that is involved here is 22600, which is beyond the upper range, right? So we cannot hear this. Therefore, you can say, therefore, this, okay, since, okay, therefore, or you can just write in the reason form, since, okay, you avoid this since here, then audible range, like that, you write, we know, or audible range, and then now our answer part, since 22600 hertz is outside this range, this audibility range for human beings, it's beyond 22600 is beyond 20,000. Okay, it will not be audible. It will, using the same language as the text, not be audible. Not audible here mean not audible to the human ear. Okay, so that concludes or completes the part for this test. 8, 9, 13, 14. You can go and give the test now. I hope that's clear, right? One more test will be there after that, 12D. That's the last test for this chapter 12 sound. Okay.